Hello and welcome to SudoKanard. I've had a lot of requests for this puzzle. It was the highest pointer in the latest WPF Sudoku Grand Prix organized by China, and Chinese author Siyuan Luo made this very difficult Renban puzzle. And as it happens, I couldn't solve it during the contest. I solved it afterwards, and it was really mind-bending at the beginning, but it's a masterpiece in Sudoku geometry. So I hope I'll be able to pull it off again. So the rule is that each of those shaded regions must contain different digits that are overall consecutive, meaning that this could be digits from 1 to 7 in any order, so dispatched along those 7 cells. So how do you start this? You start this by noting that the range must contain 7 digits, so it could be digits from 1 to 7, it could be digits from 2 to 8, or digits from 3 to 9. And in all cases, you can see that all digits between 3 and 7 must appear in such a region. So we'll focus on digits between 3 and 7, and 1, 2, 9, and 8 will play a part in the second part of the solve. So the first thing you must see regarding geometry is that this 4 sees all those cells by the standard rules of Sudoku. And we know that this region, this shaded region, must contain a 4, so there is a 4 somewhere here. So looking at this Renban region now, you see that 4 is excluded from those cells, and from this one as well. So 4 can only go in this cell. And then you see that those 4 digits, 3, 4, 5, and 6, have a rotational 90 degrees symmetry, 90 degrees rotational symmetry, that's more like it. So the same argument can be made here. This 5 can't be here, it can't be, it can't be in any of those 4 cells, so there has to be a 5 here, and then the 5 here, the 5 here. Remove all those cells, sorry about that, all those cells from being 5, and we know there must be a 5 in the Renban region, so 5 must go here. Same here, 6 can't appear here, so there must be a 6 somewhere here, and 6 can't appear here, here, or there, so there's a 6. And the same happens finally with the 3s. 3 can't be here, so there has to be a 3 somewhere here. 3 can't be here, can't be here, can't be here, so 3 is here. And that's a very nice start. Now let's have a look at how these new digits interact with the given digits. Because of this, there must be a 3 somewhere here. Because of those 6s, there must be a 6 somewhere here. The 5s here, there must be a 5 here. And finally, 4 here, there must be a 4 here. And something else we can see is that those 3s allow us to locate a 3 somewhere here. And now, this Renban region doesn't have a 3 here or here, so there has to be a 3 somewhere here. And this is where I struggle every time to find what the next step is. And it's really the same every time. Oh, there's something really interesting with 7s. You see that 7 is removed from all those cells. So in those Renban region, 7 has to appear somewhere here, somewhere here. But now, this column contains only one 7. So those won't be, and we know that those 6 cells must contain a total of 2 7s. So both 7s in those columns must be somewhere here. So we know there's a 7 in one of those 2 positions, and we can remove this 7 and this 7. So we know that 7 in column 3 must be here or there, and 7 in column 2 must be here or there. And as we know that 7 is here or there, we can see that 7 can't appear in any of those cells. Not in this one either, so 7 will be somewhere here. And something similar happens here. Because of those 7s, 7 can't be here. Well, because of those 7s, actually, they can't appear here. Well, there must be something else I need to note right now. But what was it? Is there something to do with 7s? Or must I go back to other digits? So there's a 3 here. So, oh yes, that's it. There's a 3 here, so there's no 3 in those cells. And because of this, there's no 3 here. So the 3 in this Renban region is here. And it pushes the 3 here into this cell. It removes 3 as a possibility here. So in this box, 3 has to go here, and it pushes the 5 down. Let's have a look at the implications on other 3s. So 3 is not here. It's not here, so it has to be here. We can remove this option, and 3 appears here. And we've got almost all 3s in the grid. The remaining one is here. So that's, again, a very nice implication of just geometrical patterns. And then I'm noticing this column. It needs a 6 somewhere, but because we pencil marked a 6 here, or just because of those, 6 doesn't appear here, so it has to appear somewhere here, so that we know that those options are not valid. And 6 in this region, in this Renban region, can only be here. So there's no 6 here. Because of this, there's no 6 here. So 3 positions remaining, that's not so useful. Here the digits are 4, 7, and 8. Could be useful at some point. Here 4, 6, 7, 8 doesn't seem to be useful to pencil mark all of that. This 5 here doesn't seem to have big implications. And what about this 4? As you see, I can't really find what the next step is. Oh, this 7 is not here, but there has to be a 7 in this Renban, so 7 is here. And this 7 now removes this possibility. So 7 in this Renban region is here. No 7 here. And actually the 7 in this column now must be here. And those are 4, 6, or 8. But now this 7 removes this placement for 7. So 7 is here inside this Renban region. And what about this region? Well, 7 is not here. So 7 is in here, here, or there. That's not very useful, I'm afraid. But now there must be a 7 somewhere here. And let's have a look at 6 in this column. 6 is not... 6 could be here or there. Not that useful. Where should I look next? 4, 5. 5 is not here. It must be somewhere in one of those 3 cells. Well, this puzzle is difficult. Definitely 94 points is, well, that's a valid evaluation of difficulty, I must say. Oh, what do we mean? This 6 means that 6 is not here. 6 is not here, so 6 has to be somewhere here for this Renban region. And now 6 is not here. It's not here. It's one of 2 places in this Renban region, and it removes 6 from being here. So we have a 6 in this cell. So a 6 here or there. Oh, but we know that there's a 6 somewhere here. So the 6 is not here. It's there. And now it's not here. It's there. That's really beautiful logic. And using those 6s and this one, we see that this box can only have 6 here. It pushes the 4 into this cell. It removes this 4 and pushes 4 into here. So now, about this Renban, 4 is not here, it's not here, it's here. Now 4 can't appear here, it's here in the Renban. And is there anything more to do with 4, 5, 6, etc.? Oh yes, this 5 rules 5 out of those cells. It must appear in the Renban, so it's here. 5 is not here. 5 must appear somewhere here because of this 5. It's here. This 5 rules 5 out of this cell, so that's a 5. And 7 in this Renban can't be here because of this, so it's here. In this box, 7 can only be here. And what about 5? 5 can only be here. Is there anything more to do with digits? With digits 3, 4, 5, 6, or 7. 6 in this box can only be here. 7 in this box is here. 7 in this box is in one of 2 places. 4 in this box is not here because of this 4, so it must be here or there. And here we have 2 places for 4. And this box needs a 5. It's here. So I think for digits between 3 and 7, all that can be done at this point has already been done. Let's move on to 1, 2, 8, and 9. And we see with this 2, the 2 is not here, it must be here, and those are 1 and 8. Let's ponder what happens. If this is 1, then this Renban needs a 2, and 2 will be here. If this is 8, then this will be 2 or 9. So only 2 and 9 are valid options in this cell. This column still needs 1, 8, and 9. Here, this row still needs 2, 8, and 9. And I don't see any elimination right now. These now are a 7-9 pair, and that's very useful because this Renban needs now an 8. So this is a 4-8 pair. We can remove 8 from this, and this can only be 1. There can be only 1. Here we have a 4-8 pair, so this is not 8, and this can only be 1 or 2 now, because of this 9. This is 1, 2, or 8. This column still needs 2, 8, and 9, so this is 2 or 8. This is 2 or 8, and 9 goes here. And that's interesting because this 9 plants a 9 into this cell, and this Renban needs an 8. So that's 2, that's 8, that is 6. Here we need 1 and 2, which works for the Renban logic. 2 is not here, so it's here, that's a 1. Here we need 1 and 9. Oh, but this 2 here makes this a 9, this a 2. And with 2, 1 and 8 are both valid. But 9 goes here, that's a 1. We get the 1 here. Here, that's a 7-8 pair. And here, that's a 1-2 pair. That's not an 8 anymore. 8 in the column must be here. So that's 1, and it works with a Renban. This is 1, 2, or 8, can only be 2 or 8, and 9 is removed from this and from that, from there. So all the Renban logic has been fulfilled now. It's only Sudoku. This row needs a 2, but because of this pair, 2 is not here, 2 is here. So that's 8, that's 4, 8, 4. So this 2 makes this 1, 9, 8, and 2. And the rest of the souls should be pretty straightforward. There's an 8 here, so 7, 8, 9, and 7. This is now 8, pushes the 4 into this cell. And that's a 9 to wrap the stuff up. So really, really impressive construction. Very pure, I must say, that is really pure Renban. And the logic was, the initial logic is somewhat hidden. It's not that easy to unfold, but once you see the implications, it just flows not that smoothly, but beautifully, to be sure. Thanks for watching this video, and see you pretty soon on SudoKanard.